Hello, in this video I continue the Introduction to Coding Web Games using HTML, CSS, and JavaScript series with part 6. In the previous video, we touched on drawing lines and multiple objects at once. Then we learned how to draw images to our canvas using a sprite sheet and touched on states. Now we will be adding the animation back into our objects and set some boundaries to keep them within our canvas. Then we will add a function to check for collisions between our objects. All code and a sprite sheet are available for download at the link provided below. Let's begin. As you'll recall, we left our program in this state with a canvas drawing an image to the background and a small alien rotating between two images. The background is only this part of the image being drawn from the y-coordinate of 50 and below. So it draws nothing above that. It leaves out this entire top part. And then it stretches it to fill our canvas. This little alien is only grabbing this portion, 50 in on the source x coordinate, and then every 10 frames it moves it over by 50 and starts drawing the second picture there. So every 10 frames it flips between these two pictures, giving the effect of animation. Now let's add actual animation back into our image. And the first thing we're going to have to do is we're going to have to add a few more attributes to our circle objects and image objects. The first one's going to have a key name of up, and it's going to have a value of false. This makes it a boolean, meaning true or false. The second key is also going to be a boolean named left, and we're going to set them both to false. And don't forget your commas separating your attributes from each other. We also want the same kind of up and left attributes set to false in our image object, so we just copy paste them over here. Our image object is going to get another one, however, called type, as in what type of image is this, and it's going to help us determine whether or not it's a background image or an alien image later. So next up, we're going to have to set the up and left. They are being set to false, but when we create an alien, I want to randomly set them to either up or left. So when I make an image and put it into temp alien, I can now set its up and its left to either 0 or 1, true or false. Because in code language, 0 is equal to 1 and 1 is equal to false. 0 is equal to false and 1 is equal to true, excuse me. So now I'm writing a function called getRandomNum, and I pass it a parameter of max, as in the maximum number to go to. And what this will do is it will return math.floor, meaning it'll take any parentheses or decimal point and it drops everything after the decimal point, giving you a whole number. Within that, type math.random, math has a capital M by the way, parentheses, and multiply that by max. What that does is it will give you a random number from 0 up to, but not including the max number. So if max is 10, then this will give you any random number between 0 and 9. If max is 20, you get any random number between 0 and 19. We will set max to 2, meaning we will either get a 0 or a 1, true or false. So here, once we make our alien, temp alien, we can now say temp alien dot up is equal to getRandomNum and then a 2 within there. And that will mean it'll return either a 0, meaning false, or a 1, meaning true, setting up to either true or false just randomly. Same thing with left. So left will be set to true or false randomly by calling getRandomNum and sending it a max number of 2. I've misspelled randomNum here, and this will come back to bite me in the butt in a minute. So now that up and left have been set, we need to add a few more attributes. To get these to bounce off the walls and to check collisions, we need to know things like the half width and the center x. So we're going to put these in here now. Half width is going to be an attribute function. So you write it just like we did update and draw. Don't forget your comma separating the attribute from the rest. And in half width, we're going to return this dot width, meaning the width of this, whatever's calling this, divided by 2. So half of it, just like it sounds. Same for the height, except with wherever it says width, now you say height. So half height becomes return this dot height divided by 2. Now we're going to need a center x and a center y, and this is the x coordinate of the exact center of our rectangle. So to get that, we type center x colon, capital X if you don't mind, colon, function, parentheses, curly braces, do not forget that comma, and we're going to return this dot x plus this, and we now can call that half width function to give us half the width. So when you add half the width to the x coordinate, you automatically get the x coordinate of the middle, the center, x. And here I've had a brain moment, and I forgot that I had the half width function. And I started to write out this dot half times 2 divided by 2. Yes. And then you'll see me also realize that I've forgotten my comma after I copy paste. So then I hit the comma, and then I put my next one, and instead of x, I'll put y, and then put y here as well. And instead of half width, now I want the half height. So this dot y plus this dot half height is the center y, the coordinate, center coordinate for your y. Okay, so we've got that taken care of. What we need to do now is we need to add a little bit of logic to the update function to check to see if it's within some boundaries. And if it's not, if it's going without of the boundaries, we'll turn it around. So first we check to see if this dot y, meaning its y coordinate, is less than or equal to 0. This dot y, again, is in its upper left hand corner, so this means the top of your picture. And if the top of your picture is less than or equal to 0, that means it has gone past the top of your canvas. And if your picture touches the top of your canvas, that means it was traveling up, and we want to turn up to false so that it will travel down. So we take this dot up and we set it equal to false. And much the same with the bottom, except that this time you have to check to see that this dot y, so if this dot y plus this dot height, because a rectangle's y coordinate plus its height is at the bottom of the rectangle. So now we're asking, is the bottom of the rectangle greater than or equal to the height of the canvas? Because if this is true, that means our rectangle is starting to go off the bottom of the canvas. And we need to, that means it's traveling down, that means up is false, so we need to set up to true to make it go up. Pardon me. Okay, in the x coordinate, it's much the same. If this dot x is less than or equal to 0, that means the left side of your picture has either butted up against or gone past the left side of your canvas, meaning it was traveling to the left, and you need to make left false so that it will now go to the right. And if this dot x, meaning its left side, plus this dot width, that brings you all the way to its right side. So if the right side of the picture is greater than or equal to your canvas dot width, that means that your picture has started to go off the right side of your canvas, traveling to the right, and you want to make it go left. So you would say this dot left is now equal to true. So for now, your image knows what it would do if it meets these boundaries, but it's not actually moving anywhere. It is still static, so we need to add the logic to get it to go up, down, left, and right. So we check to see if this dot up is true. And if it is true, if this dot up is true, then the if statement will be true and it will run. And we'll say if this dot up, we want to go up by subtracting from the y coordinate. Because remember, to go up means to subtract from the y coordinate. So this dot y will minus equal, and for now let's say 8. That's a good number just to test it. But if this dot up is false, that means we want it to go down. We want our object to go down, and that means adding to the y coordinate. So just the opposite, we say this dot y plus equal 8. And almost the exact same for the x coordinate and left. If this dot left is true, then you want the x coordinate to go to be less, so you subtract 8 from it. And if you want it to go to the right, you add 8 to the x coordinate. Okay, so now if we've done this correctly, when we refresh our page, our little alien should start moving either to the right or left randomly and then bounce off of the walls when it hits the edges of our canvas. You'll see I've found a mistake. So that is why you right click or alt click on your page and you hit inspect and you find your inspector or your console, and then you should find the error, get random num. It says it's on line 84 on my .js, line 84. So I go to YouTube tutorial.js, go to line 84, find where it says random num and change it to random num. Right there. Whoop, ran 0 num. Okay. Now I believe, if I recall correctly, this works. It goes a little slow. I meant for it to go faster, but it's working. Yay, it's bouncing off the edges. You see we have one lonely little alien bouncing off the edges here. I'll just show it one more time so you can see it actually reverse. It's when it hits the top, it tells it to go down. When it hits the side, it tells it to go left. I want to actually draw more than just the one alien though. So up here, hold on, I have, let's see, what did I do? Pardon me one moment. Yes, okay, so I need to determine, before I forget, I need to go in here, everywhere I say make image, and I need to pass it a type so that my aliens know that they're aliens and that my background knows it's a background. And this will come into handy later. It'll come in handy, not come into handy, excuse me. So just like before, I have to accept type as a parameter when I make an image, and then I have to set type into my image, just like everything else. So now when I call make image, I have to send it a type. And it can be really whatever you want. I chose alien and background because that is self-explanatory. This one's going to be of type alien. So every time I make an alien, it'll set it to type alien. And this one, I'll set it to type background because it's my background. I could have really written anything in there just so long as I didn't write alien again. Okay, also we need to make our aliens more dynamic. We're hard coding each alien to start kind of off center slightly. And remember, to make things dynamic, we accept the x and the y coordinates as parameters. And then when we call the function, we have to then send those x and y coordinates like that. But since I don't want to just make one alien, I want to make more than one, let's bring out the old for loop. And in this case, we're setting var, again, var I to 0. Let's do 4 aliens. So I'm going to do I, make sure I is less than 4, and then colon, and then I++, write it exactly as you see it there. Then you can move your make alien function into here, so it'll run it 4 times. But remember, we need to make it a little more dynamic so it doesn't just print them all at the same spot. So let's multiply the x coordinate by I. Encase it in parentheses, and then multiply it by I so that make sure you do your math right. Now we should have 4 aliens. Some of them start off screen, but remember, anytime they're to the right of the screen, they make their way to the left of the screen, towards the screen. And then once they get inside the screen, they can't escape. It's like a little alien trap. There you go. But you see how they are just kind of running right over each other. We're about to fix that, and we're going to add some collisions. We're going to add a function called hit test rectangle to test to see if 2 rectangles are touching each other, and then we're going to do something when that happens. In order to do that, I'm going to have to create the function right about here. We could just, above our other function. I like to keep all my functions together. And this function's called hit test rectangle. Now, just follow along and type exactly as I type here, R1, R2, in the parentheses. Type it exactly as I type here, and I'm not going to explain too much while I'm typing because I don't want to mess it up. I've actually prepared a small 5-minute video that explains line by line exactly what is happening in this function so that you can grasp it better. So just know that you have to put var hit equals false, and then go down a bit and hit and type var vx as in variable vx is equal to, and this is where we're going to use our half widths and center x's is around in this part. So var vx is going to be equal to r1, the r1 center x, and it's a function. Make sure you call it with your parentheses. So r1 center x parentheses minus r2 center x in parentheses. Now that's the difference in the r1 and r2's x variables. Now we need the difference in their y's, in their center y's. So we get var vy is equal to r1 dot center y parentheses minus r2 dot center y in parentheses, semicolon. Okay, now we need two more, one called combined half widths and combined half heights. So var combined half widths, and this is self-explanatory. We're going to combine the half widths of r1 and r2. So to do that, you do r1 dot half width, and it's a function, so you got to call it, plus r2 dot half width parentheses semicolon. Same thing with height, but again with the heights. So combined half heights is equal to r1 dot half height plus r2 dot half height. And bear with me, in the video that you're about to see, after we're done, I swear I'm going to show a little 5-minute video, and there's a spot near the very beginning where I misspoke and I said 20 by 20 and I meant to say 20 by 18. And I'm not a video editor, so when you watch it, let's see if you can tell where I made the mistake. But for now, type if. What we're going to do now is we're comparing the absolute value of vx. So that's math.abs parentheses vx. We're comparing to see if the absolute value of vx is less than combined half widths. Absolute value means you're just dropping any sign. If it was negative, now it's positive. If it was positive, it stays positive. It just drops the sign. So if math.absolute vx is less than combined half widths, that means your rectangles are close enough to be touching. And you need to check to see if the absolute value of vy, so math.absolute value of vy in an if statement, is less than combined half heights, then they really are touching. If both their vx and their vy are close enough that they're less than their combined half widths and heights, then that means they are touching, and hit is equal to true. You have a collision. And this is the only case in which you'll have a collision, because if the math.absolute vy is not less than combined half height, you want to do something else, and you want to set hit to false, because there is no collision. Likewise, if math.absolute absolute value of vx is not less than combined half widths, they are also not touching, and you will put false into hit, or you will set hit to false. And the last thing you have to do is you have to return hit. And now that we have a function called hit test rectangle, we can check for collisions. And I'm going to briefly show you a video that will explain this in greater detail. And I'm going to do that now. This is the function we just coded. The grid seen here represents a simplified canvas that is 20 pixels wide by 18 pixels tall. All coordinates are relative to the grid's upper left-hand corner. It is 0, 0. The yellow rectangle labeled R1 is rectangle 1, and the one labeled R2 is rectangle 2. R1's x-coordinate is 11, and its y-coordinate is 9. R2's x-coordinate is 13, and its y-coordinate is 3. In these first two lines of our function, R1 and R2 are passed as parameters, and a variable is created named hit and set to false. This is the variable we will return when the function is complete. A rectangle's center x-coordinate is found by adding half of the rectangle's width to the rectangle's x-coordinate. In this example, R1's x-coordinate is 11, and half of its width is 2, making its center x equal to 13. The result obtained by subtracting R2's center x from R1's center x is placed into a newly created variable called Vx. In this example, R1's center x is 13, while R2's is 15. Vx is determined to be -2 by subtracting 15 from 13. A rectangle's center y coordinate is found by adding half of the rectangle's height to its y coordinate. In this case, R1's y coordinate is 9, and half of its height, is 2. This means that R1's center y is equal to 9 plus 2, or 11. Likewise, the result obtained by subtracting R2's center y coordinate from R1's center y coordinate is placed into a newly created variable named Vy. As seen here, R1's center y is 11, while R2's is 5. This makes Vy 11 minus 5, which is 6. In this line, a variable called combined half widths is created. It is then set equal to the sum of half of R1's width plus half of R2's width. In this example, R1 and R2 are both 4 pixels wide, so half of their widths is 2 each. 2 plus 2 is 4, so combined half widths is equal to 4. A new variable is created in this line and called combined half heights. It is then set equal to the sum of half R1's height plus half of R2's height. Again, since R1 and R2 are both 4 pixels tall, both of their heights cut in half is 2 each. 2 plus 2 is still 4, so combined half heights is equal to 4. Now that we have values for both Vx and combined half widths, we can use an if statement in the next line to check whether or not the absolute value of Vx, meaning the value of Vx with the positive or negative symbol simply ignored, is less than combined half widths. In our example here, the absolute value of Vx is 2. Pardon me. And combined half widths is 4. 2 is indeed less than 4, so our if statement is true. This means that the next line to be read will be the next if statement. As with Vx and combined half widths, we can now compare Vy and combined half heights. In this next line, we use an if statement to see if the absolute value of Vy, which in this case is 6, is less than the combined half heights, which is 4. 6 is not less than 4, so this statement is false. In this scenario, hit is set to false, and the function has finished running except for the final return statement. As you see here, I have moved R2 down until R1 and R2 are just touching. I want to show you how the line of code below would be resolved. In this case, the difference between R1 and R2's center y's is only 4, and combined half heights is still 4. 4 is not less than 4, so the statement remains false. Again, hit is set to false, and all that is left to do is return hit. Let's look at another scenario. In this case, R1 and R2 are slightly overlapping. The difference between their center y's is 3, making the absolute value of Vy 3, while keeping combined half heights at 4. This 3 is less than 4, so this statement is finally true. This causes hit to be set to true and then returned. This is a collision. To be thorough, I wanted to show you what would happen if the first statement had been false, if the first if statement had been false, pardon me. I again moved R2 so that the difference between R1's center x and R2's center x is 4. Their combined half widths is still 4, and 4 is not less than 4, so this statement is evaluated as false, and hit is set to false, and after hit is set to either true or false, the last line of our function returns hit, and our function is exited. Okay, so hopefully you will understand hit test rectangle a little bit better, and you'll understand what's going on here and know what hit means when it says true and what hit means when it says false. So now in update we can use that function. We can come right underneath the update function at the very top, we can say that every time this updates, we want to check it against every other alien in sprite array and see if they're touching. So we say for, and I start to write alien, then I catch myself because earlier I'd been writing sprite of sprite array and I don't want to change things. So I come back and I say, no, let's keep it the way it was. So for sprite of sprite array, we want to do something. And since we don't want to check each alien against itself, because of course it will be touching itself, it'll be exactly where it is, we want to make sure that it's not checking against itself. So we say if sprite does not equal this, that means we can go ahead and continue with what we're doing because it's not the same sprite. We also want to check to make sure that it's an alien and not the background. We don't want to check to see if it's hitting the background because it will be hitting the background. It is right on top of the background. So we say and it's a double ampersand. When you're in an if statement, you have to give it a double ampersand to mean and. So we're checking to see if sprite does not equal this object and that this object is an alien. If it is, we are going to create a variable called hit and set it equal to hit test rectangle function. It's a function, so you call it. And we send this and the sprite. We send two rectangles. You have to send two rectangles, remember? R1 and R2. So we're sending this and a sprite. And now if this object and the sprite are touching, it will return true. So we need to check to see if it returns true or false. And we say if hit, meaning if hit is true, we do something. But for now, let's focus on the else, because if hit is not true and it's not touching anything, we want to do something else. And what we want to do is just exactly what we've been doing down here. All of this, except all the way up to count. Leave this dot count out of it. But all of this can go into that else statement, except for the part where you add to the x or subtract to the x and y. Because if you do that in a for loop, you're going to be doing it multiple times every frame, and it's going to look ridiculous. So you pull that out and make sure it is outside of the for loop, just outside the for loop, and we should be good. Now my logic is not sound here, but follow with me and we'll fix it later. It's going to be a minute. So up here, if there is a hit, if you are touching, we want to do something. And for now, let's keep it simple, and we're just going to blow up our aliens. I have briefly forgotten that we need temp alien.hit. So up here, when you make the alien, give it one more attribute and say temp alien.hit equals false, meaning it is not hit. And right here, in our logic to check to make sure that this is a alien, we're going to need, oh, I'm sorry, no. Right here, where we check the count, we also want to make sure that this alien has not been hit, because we don't want it to move anymore. If it's been hit, we don't want it to move. So we keep it there. Okay. Pardon me, sorry about that. So now, if this hit is true, or if the variable hit is true, we set this dot hit to true, and we tell it to destroy the alien, and we pass it an alien called this. Now we haven't written destroy alien yet, so we need to come up here and we need to write function destroy alien. And I noticed I misspelled destroy, and I don't notice it when I was writing this. I didn't notice it until much later. So just for now, ignore that and write destroy, not dextroy. Function destroy alien, capital A, and then we take an alien as a parameter. And what we do with that alien is we tell it alien.sourceX equals something. We're going to push the source X over so that it shows a different picture. Because whichever one of these it's showing, left or right, we want it to automatically move over to this picture and look like an explosion. So I have to set its source X to 50, 100, 150, and it'll show this picture. So I will set alien.sourceX to 150 so that it'll show the explosion. And then I'm going to do something new called set timeout. And what this does is, this is a function, so you have to call it like this, and this waits a certain predetermined amount of time before calling this function that I'm writing now. So you write in here function, close parentheses, open close parentheses, open close curly braces, then a comma. Then this is where you give it the time. And it deals in milliseconds. So if you put 1,000 here, that's 1 second. 1,000 is 1 second. But I only want like 2/10 of a second. So I'm going to put 200. And that'll be a real fast, short animation. And once the 200 seconds is over, I'm going to remove alien from the sprite array. Remove the alien that I want. So I'm going to ask sprite array to splice. And what that does is it takes the object out of the array. But I need to pass it 2 parameters. And the first one is I need to tell it where the object is in the array. Like what index, where is it at? So I have to call upon sprite array again. So I say sprite array, and then I ask it, or I say dot index of. What is the index of? And then close parentheses. What is the index of the alien? So that'll return the index of where the alien is in the array and set it there. And then you hit comma, and you tell it you want to erase 1 item from the array. So now, when destroyed alien is called, it should look like a little explosion, and then it removes the array from sprite array. And this is where I am realizing I've made a mistake. So I instantly inspect my page to go to my console, and I always like seeing errors here because it tells me exactly where the problem is. For example, hit test rectangle is not a function. I want hit test rectangle. So I go to line 119, and I find the missing C, and I put it in there. And then I believe there's one more error here. I shouldn't have closed my console because there's another error. I just have to reopen it. And this one is telling me that destroy alien is not defined on line 122 when I know it is. But this is where I realize that I have named it destroy alien. And I'm like, oh, yeah, destroy alien. Okay, so we're making progress. It's not exactly right. You can tell it still destroys the alien, but what in reality is happening, and I can take a few moments to tell you this because I stared at my screen and I wondered what the heck I was doing wrong for a while now, so I have a moment to tell you that it's calling the hit test rectangle function on the background. And of course, the aliens are colliding with the background because they're printed directly on top of the background. So within the very first frame, every alien that is printed in the canvas is printed across the background and is instantly destroyed because it's colliding with the background. It takes me a while to realize this. Do type and this dot hit up there. I'm not sure that that was the problem, but I know that it helps, and any logic that helps is never bad. So this is me. This is one good thing to do when you have a problem is you go through your functions and you make sure that every jot and tittle is correct. Every period is there, every parentheses, nothing is misspelled. Because your computer doesn't always find spelling errors. If it thinks that's what you meant to put there, then it's not going to correct you. So after a while, and again, please bear with me, but this is important to see the process. This is like, watching the sausage being made. You got to see that you have to go back and you have to go through every line of code sometimes that you've just written to make sure you did everything right. But then eventually it'll hit me, oh my goodness. I'm not making sure that up here in temp_alien.update, the function, I check and I make sure that the sprite is not the same as the object I'm checking it against, and I make sure that this dot type equals alien, but I don't make sure that the thing I'm checking it against is an alien. So that is why it checks it against the background. I have to come up inside that if statement, and I have to add another ampersand section, and I have to make sure that I'm checking against other aliens, because as it stands now, I'm checking against the background, which is why they all get blowed up. And it takes me a moment. I play with it. I think hard. Smoke comes out of my ears. And then it hits me. And this is a good way, or a good time to explain what the ampersands mean. The double ampersand. That means that each statement within that if statement, all has to be true. So sprite it can't equal this, it has to not equal this, and its type has to be alien, and it cannot, this dot hit cannot be true. All of that has to be true for this statement to be true. If one of those is false, the entire thing is false. I believe this is me realizing what I've made, the mistake I've made. And then I come in here and I tell it, and sprite.type also has to equal alien. Don't forget to put another double ampersand. So now you have 4 statements that have to be true. And there you go. It's actually working. You can't tell because they're going so fast. So I'm like, whoa, wait a minute. 8 maybe is too large of a number. Let's go back in here and let's settle this down a bit. 5 is a reasonable number. Let's see what it does. Let's slow them down. You see them exploding now. You see that they do in fact explode upon collision, but they're still going a little fast. So let's just set this to 1. And there you go. Boom. Poor guys. I wish they're wishing they had brakes. They got no brakes. I didn't think there were enough aliens to bounce around and crash into each other. So I come up here, and where I make the alien, instead of just doing 4, I think I change it to 10. And again, remember, a lot of these are being drawn off the screen, but they go towards the screen until they reach the screen, and then they bounce around in the screen. There's a collision. Boom. Here comes guy off the side. Ooh, they just passed each other. They barely made it. All right, let's see who gets it. Who's going to get it? Boom. Oh, all 3 of them got it. There you go. Congratulations on completing part 6 of the series. Now, you may already have enough coding knowledge to build a playable game. Keep making this code your own and have fun with it. In the next video, we'll be adding a little spaceship and learning more about states. See you there.